This video is part 4 of Chapter 6, Thinking and Intelligence for PSY 110S, the Psychological Sciences. We're going to shift now in this last part of the chapter to exploring various theories that psychologists have developed for describing the construct of intelligence. We'll start with Spearman's theory. Charles Spearman believed that there were two functional domains, basically, or factors that represent intelligence, and recognized that Spearman was a bit of a psychometrician. He was really into the math of it, and he argued that there was a general intelligence, so a global kind of intelligence that he called a G factor, and then specific abilities that people could have, and those were S factors. So he focused on generating like a global general kind of measure, as well as specific ability scores for kind of describing an individual's level of intelligence. He believed that, as far as being successful, and by that being successful in school, was largely related to the G factor. People who did well on one subset, even if you're looking at the S factors, people who did well on one tend to do well on many of them, as opposed to doing well in only one or two. So generally, what he was arguing was that if you have high G factor intelligence, you probably have high S factor intelligence across multiple domains. People who did poorly on one subset also tended to do poorly on the others. So what that he inferred was, if you have lower general intelligence, it often translates into lower subtest scores on specific abilities as well. Thurstone argued that there were several different types of abilities that were strongly related to this global sense of intelligence. Notice how academic these are, and how academic they are, particularly in a Western context, where compulsory education is the norm. So Thurstone focused on verbal comprehension, number sense, spatial skills, like shapes and position, things like that, speed of perception, word fluency, memory, and reasoning. Sounds like all the tests you've ever been given, like if you've been given intelligence tests in the past. These are the basic skills that tend to be hit on those tests. These abilities, and Thurstone, like many of the people working in this space, really into the math of it. He was a psychometrician, and he used factor analysis, which is a statistical approach that classifies items together that tend to be highly intercorrelated and then labels them as a factor. So, for instance, you'd have a bunch of items that are developed to test intelligence. When you use factor analysis, it will pull out the interrelated items, and you'll have clusters of them. So one factor would be labeled verbal comprehension, another factor would be labeled number facility, and so on. And, again, a lot of these approaches really emphasize the skills that are most related to school performance. Cattell and Horn proposed, they looked at this in a little bit different way. As opposed to content that was being tested, they were more on process. So Cattell and Horn proposed two broad types of intelligence, especially as they were looking at aging. A lot of the early intelligence testing fell in two domains. Either they wanted to find people who were very vulnerable in terms of their intellectual capacity and provide them with remediation or protection, or they were looking at developmental questions, specifically with children. Cattell and Horn were more interested in aging. So they talked about the difference between fluid intelligence, which is, the usual stuff that we understand as being related to school performance, abstract reasoning, memory, speed of processing. And then there's crystallized intelligence, and that's more about that base of information that you acquire over the course of a lifetime. So accumulated knowledge, wisdom, as well as, accumulated verbal skills and the ability to deal with numbers. So they proposed two different forms of intelligence there. Getting even more complex, because many, over the decades got uncomfortable with the idea that these tests were so heavily biased in the direction of traditional classroom learning in very specific domains. Language, math, spatial reasoning, and problem solving, but ignoring a whole bunch of other areas of experience. So Gardner, and it was a controversial theory at the time, and it remains a point of contention, but he argued that there were 8 independent intelligences that didn't necessarily predict one another. So you start off with the classics, but then you quickly deviate away. So traditional tests would identify linguistic skills, logical, mathematical skills, and spatial skills. But then Gardner added things like musical skills and musical intelligence, bodily kinesthetic skills, intrapersonal, which means knowing yourself, and interpersonal, reading other people, and naturalistic skills, which are related to discerning patterns in the natural world. So he wanted to broaden, and Gardner's book actually sold very well in popular culture. It was a point of controversy among scientists, but the populace loved it. So regular everyday people who often found themselves to struggle in those linguistic, logical, mathematical, spatial areas, and maybe not really be that successful in school or just not enjoy school, even though they did fairly well. They identified with this idea of multiple intelligences, especially in not traditionally academically valued areas. So you could have a person who was just had a high degree of physical skill, which typically wasn't described as being related to intelligence. But there's a great deal of brain work that goes into being a highly skilled athlete, for example. In musicianship, he argued that the ability to do the things that musicians do, whether they're composing or playing or both, involves intelligence. So he was making this broad argument that there's more to being bright than just scoring high on the first 3 bullet points. There are other ways of expressing brilliance. Sternberg dialed it back a little bit. Instead of 8, he focused on 3 broad areas of intelligence. Analytical intelligence is basically the standard things that we are all used to being assessed on. And these are the basic things required for good academic performance. But he didn't think that was, the be-all and end-all. So he also talked about what's called practical intelligence. Things like having good common sense, being able to work within the environment that you're familiar with to get the things that you need. So being smart about navigating your particular world. And then finally, creativity. Sternberg's approach was seen as a little more streamlined than Gardner's, but Sternberg was kind of making the same basic point, was that we can't just focus on analytical intelligence because we are missing whole realms of people who are bright and successful and capable. They just may not be hitting in those areas that we typically define as essential, like the analytical areas. So he was trying to broaden it, but not make it overwhelmingly so. Now, Stanovich, he's more on the philosophical side of the argument. He argued that intelligence alone isn't enough to explain differences in people's abilities to do the thing of thinking. Intelligence, in Stanovich's thinking of it, you have to think about the ability to think and act rationally. That isn't something that is actually assessed in intelligence tests. Thinking and acting rationally in the moment isn't going to be assessed by a paper and pencil test. It's going to be tested in actual situations where you have to make decisions and behave rationally, and make choices that will lead to those outcomes. That's another part of intelligence that has really kind of been missed. He used this concept, or Stanovich used this concept of disrationalia to describe the failure to think and behave rationally. Humans do it all the time. I'm a social psychologist. Believe me, people are less rational than we would really like them to be. And those who behave rationally despite the temptation to do otherwise, Stanovich would suggest are intelligent. Now, before we leave these theories, we need to have the broader discussion that happens in psychology, regardless of whether we're talking about intelligence or other things. But the nature-nurture debate has been a part of the intelligence area from the beginning. Remember how I said that Galton was a eugenicist? He believed that intelligence came from genetics and was passed from parents to children. If parents weren't bright, they were going to have children who were not bright. And, moving that from science to politics, that could lead to selective decisions to allow some people to reproduce and other people not to. And before you think, oh, well, that's science fiction, in Europe and the United States, and I would guess in other parts of the world as well, but I'm most familiar with the Western world, there have been policies implemented that in really disturbing and in some cases horrific ways were based on this argument about eugenics. And that includes forced sterilizations, where there were policies put in place to eliminate the potential for certain kinds of people, sometimes based on test scores, to not reproduce. So let's put the nature-nurture argument in the context of intelligence. Most psychologists today believe that both heredity, genetics, nature, and environmental experiences shape what we refer to as the broad concept of intelligence. The disagreements are about the relative degree to which these factors contribute, and in what area of intelligence. Intelligence is complex. As these competing theories show, if we go with the Gardner approach, and there are all 8 or more categories where intelligence can show itself, each one of those potentially could have a different level of contribution of nature and nurture. The basic agreement, though, is both matter, and both matter in ways that are complex to describe. So let's start on the nature side. What kind of evidence that we have that biology, genetics, heritability factor into intelligence? The way this is determined is by doing genetic similarity studies. And what they're looking for there is the relative contribution of genetics and exposure to the environment on intelligence. Identical twins, at least at the very start, have 100% genetic similarity. Fraternal twins have 50. So 2 unrelated people, 0. Now, if intelligence were 100% hereditary, sorry, the average correlations between intelligence scores should be should increase as the degree of genetic similarity increases. It should decrease as the degree of genetic similarity decreases. And this, in fact, has been found to be the case. So when we talk about heritability, there's a formula for determining the degree to which variability in any given trait is due to heredity. And what we find with the various areas of intelligence, particularly those that have been measured a lot, like those ones that are tied to school-based performance, that they're, when you're looking at identical twins, they tend to have a high degree of similarity in their scores. At the same time, though, there are there's evidence of environmental influences as well. Identical twins that are raised in the same environment, their intelligence test scores are strongly positively correlated. So 0.86. They're raised together, and that's critical. So you've got both influences, genetic and environmental, in play. If identical twins are raised apart, the correlation goes down. Not a ton, but it goes down a significant amount. So what that shows is that you have that base that comes biologically of similarity, but then environment can impact the degree to which that baseline capacity is expressed. So when we're looking at twin data and sibling data, the average correlation for fraternal twins who are raised together is about 0.6. So, they're carrying, half their genetics in common. Identical twins reared apart is about 0.72. So what that kind of suggests is that the identical nature of the genetics of twins who are identical twins boosts that degree of similarity between the twins. When they're fraternal twins and they're in the same environment, you have some genetic overlap that then again is boosted by that shared environment. So it includes the influence of heredity and the environment. For ordinary siblings, as in not twins, not born at the same time, you see a drop, even when they're reared together, from 0.6 to 0.47. So there, the environmental influences for fraternal twins is more similar for ordinary than it is for ordinary siblings who are different in age. So what that suggests is that you were born at the same time, you were raised by the same people in the same environment, and that kind of flattens out the environmental impact. Whereas for ordinary siblings who are raised in the same place, having the same kinds of environmental exposures, but they're separated by time, which means the type of environmental exposures differ. So they're going to have different kinds of impacts at that time. We can also look at adoption data as a source of information. When researchers say there's a modest correlation, they mean it's a medium correlation, like 0.2. A modest correlation between IQ or intelligence test scores between adopted children and their adoptive parents as the children age, because that would suggest nurture as the argument. That correlation starts to diminish as kids get older. The correlation between scores for adopted children and their biological parents, however, as your authors note, goes up as children age. So what this kind of suggests is that intelligence of some kinds is really is predicted with some degree of certainty, and I'm really trying to select my words carefully. If you know something about the intelligence of the biological parents, you can make some reasonable predictions about the children. Nature plays a larger role than environment, in measures of intelligence of particular kinds. So again, most of what we're measuring as intelligence are those particular areas, those domains related to academic success. Verbal facility, math, spatial reasoning, and so on. So the controversies, because you can guess that, these are very fraught discussions. How mutable, how much should we try to help kids learn if the suggestion is that their parents weren't particularly bright? Why should we invest in trying to improve the performance of their kids? Just remember that heritability, as your authors put it, is an index of the degree of variation of a trait within a population due to heredity. Basically, it just gives you a baseline. The degree to which a trait is going to be different within that population, and that variation is explainable by heredity and hereditary factors. There's a range. So genetically, you're born with a certain range that is not well defined scientifically at the present time, but the assumption is you're born with a range of intellectual ability and capacity. The environment you land in, so the quality of your environment, everything you're exposed to, and that includes prenatally, postnatally, across the lifespan, is going to impact where in that given range you're going to be able to express those inborn abilities. So for intelligence, what we have to date, most of the research right now suggests that about anywhere between 50 and 70% of the variability in IQ or intelligence test scores is due to hereditary factors. Now that looks like super large. Well, 50 to 70, that means you have anywhere from 50 to 30% that is explainable by the environment. So it is not 100% determined by heredity. It's not 100% determined by environment. It's an interaction between the two. Now, your authors conclude with a discussion of something called the Flynn effect. The Flynn effect involves this documented finding in the United States and other Western cultures that intelligence test scores have been steadily improving over the last 100 years. Now, this doesn't necessarily mean that people are getting smarter. However, it may suggest something more related to people getting more practice and getting smarter at the skills that are more important in their particular society, especially in verbal, abstract reasoning, scientific thinking, mathematical skills, spatial skills, those sorts of things. So if we really drill on that and we suggest that the culture highly values these things, and we communicate to kids throughout their entire lifespan, and we communicate to their parents when they're little that these are the things that translate into a good life, you're likely to see scores in those areas improve, not necessarily because the species is getting any smarter, but because we're emphasizing and perhaps overemphasizing some of those specific abilities in the way that we raise kids, in the way that we teach them, and what we expect them to be able to do in their advanced schooling, in their careers, and so on. Some researchers have also noted that any kinds of improvements in so-called fluid intelligence over the last century, that those have been greater than for crystallized intelligence. And, intelligence test score gains have increased, but the size of the gain has been diminishing over time. So the scores keep trending up, but the amount of increase year to year is diminishing over time. So there have been a lot of potential explanations for these findings. And, some researchers are actually showing the Flynn effect is starting to show up in so-called developing countries as well. But there are a lot of proposed explanations. For example, a lot of environmental factors like improvements in nutrition, hygiene, medical care, education, reduced family size, all of those things, economic stability, political stability, all of those can have an impact on how people perform on these kinds of tests. So it's not so much that people in the Western world or wherever you're running studies of this kind are getting smarter. It's that their world is, number one, capable of delivering to them the kind of environmental stability, health-related factors, and educational experiences that make it more likely that people can perform to their native ability. So if you go back to that idea of here's what you're born with, now how can we maximize your ability to express what you're born with? The Flynn effect, in a sense, explains how that can push that biological buffer to its highest capacity. When people have advantages, when they have good nutrition, when they have good medical care, when they have solid education, when their families can invest a great deal of their resources in smaller number of children, they tend to be performing better on these kinds of tests. So that's your whirlwind trip through the study of intelligence. And that concludes my coverage of Chapter 6.